Hey everyone, and welcome back for part 2 of Simple Experiments in Psych 3510. Just a quick recap of where we left off. We are sort of defining two major groups of types of experiments. One type of experiment is going to be called independent groups. The other is within groups designs. Again, an experiment is something where a situation where we manipulate an independent variable. So we change something about the world, and then we measure its effect, right? Its impact on a dependent variable, which is our outcome. So these terms that you see are sort of synonymous. Independent groups or between subjects means we have two or more separate groups of people. So we have group A, group B, potentially group C, group D. A within groups design is one in which we have a single group, so group A, but group A goes through multiple iterations of the experiment, essentially, right? So a single group of people experience the experiment multiple times versus separate groups of people experiencing the experiment once. There are multiple sort of types of designs. We're going to go through the very basic ones here. So first, independent groups. Again, these are designs where we have multiple groups of people, and we are going to do different things to each group. The classic example I like to use is a medical study. Right? We might have a control group that does nothing. Then we have a group that might get 25 milligrams of the medicine. Right? So we have group 1 who does nothing, group 2 who gets the medicine. Right? So we have independent groups. An example of this that we've already seen is called a post-test-only design. This is the laptop versus longhand or written notes example from earlier in the lecture. So this is an independent groups design because the people who use laptops are different from the people who don't use laptops, who write their notes by hand. Right? We have two different groups of people, and then we measure them on their comprehension of the material, right? That's our outcome, our dependent variable. So did you take notes with a laptop? Did you take notes with pen and paper? How well do you understand the material, right? That's the experiment. Type of notes is the independent variable. The comprehension is the dependent variable. So this is a post-test only design because the first thing we do is put people into groups. Then we manipulate something about the world, in this case, their note-taking, and then we measure the outcome. So we only get a measurement post-test, right, after the thing has already happened. We don't actually know anything about these people pre-test before, right? Pre-test would be like giving them a comprehension test first, then manipulating note-taking, and then looking at their comprehension after. That's not what we do here. We don't have a pre-test, right? All we do is a post-test. We manipulate, and then we post-test. So this is our most simple independent groups design. It's fine. You will see this a lot in the literature or various literatures. There's nothing wrong with this type of experimental design. But when we can do it, we actually prefer a pre-test, post-test design. So I want you to imagine that you study, academic achievement, right? That's your area of scientific interest. You want to understand how to help people achieve academically better. You think that a mindfulness meditation class is going to help people. Seems reasonable, right? We're going to reduce stress. We're going to maybe help people focus, yada, yada, yada. Mindfulness is going to help people's academic achievement. So when you're collecting data on a topic like this, it would be really helpful to have a starting point for everyone, right? A pretest of how well do all my participants do before my manipulation. Then I'm going to manipulate the variable, and then I'm going to assess their post-test, right? Their outcome on the back end after the manipulation. So we almost get a baseline, then we change something, and then we measure again post-test. So what we see here is random assignment into two groups, and we measure everyone's verbal GRE scores, right? The GRE is like the SAT, but for grad school. So we want to see how people do on the verbal portion of the GRE. So we get a baseline score. How does everyone do on the GRE? Then half of our participants do some mindfulness meditation classes. The other half of our participants, sort of what you could call the control group, they do like a nutrition class, right? It doesn't have anything to do with performance. It's just a class they're taking to give us a nice control, a nice comparison group. So what we're going to actually do here is look at the differences in pre to post test across our types of classes. So we like this pre-test, post-test design because we get a starting point of everyone's verbal GRE scores. Then we introduce our independent variable, and then we measure the outcome again in a post-test design, and we can compare that outcome to the pre-test. So what this helps us do is control for lots of person-level variables. Some people might have studied for the verbal GRE before. Some people might just be sort of naturally more gifted at verbal abilities than, let's say, mathematical abilities. So by having a pre-test to post-test, what we actually do is remove those individual level variables, because now we're just looking at the effect of the class itself, because we know where everyone stood before the class, we know where everyone stands after the class, and so we can parse out that effect and just look at the class. So this is, again, an independent groups design because we are putting people into two separate tracks, if you will, two separate groups. One group is going to end up getting a mindfulness class. The other group is going to get a nutrition class. So when you're trying to look at an experimental design and decide, is this an independent or a within groups or a between subjects or within groups design, just ask yourself one simple question. Does a participant in the experiment experience one level of the independent variable, or do they experience multiple levels of the independent variable? So I'll say that again. If you want to decide if an experimental design is between or within subjects, ask yourself one question. Does any given participant experience a single level of the independent variable, or do they experience multiple levels of the independent variable? In this case, we can see that any given participant is going to be randomly assigned into one of these groups, and then they will only experience a single level of the independent variable. Our independent variable is like type of class, right? That might be how we define independent variable, type of class. And you either get mindfulness or you get nutrition. You don't get both, right? You get one or you get the other. So you only experience one level of the independent variable. That makes this a independent or a between subjects design. Now we can contrast that with within groups designs, and the hallmark of a within groups design is the opposite. Basically, any given individual will experience multiple levels of the independent variable. They will essentially You can think of it this way: they will do the experiment multiple times in different situations, right? So instead of having multiple groups, we have one group that does multiple things. That's a within groups design. So a nice simple example of this is a concurrent measures design. And in a concurrent measures design, the participant experiences multiple levels of the independent variable simultaneously. So, for example, a lot of social psychology focuses on, and maybe perceptual psychology focuses on the way people interpret or process or make decisions about faces. Faces are very important for human psychology. Lots and lots of work on the way people, interpret and process faces. So what you might be asking are something about gender differences in faces, female versus male faces. And so what you can do is put like on a screen simultaneously a male face and a female face, and you ask participants to make some decision or make some rating, or you can measure things like their eye movements. Here we have what's called a looking paradigm, where maybe what we're measuring is how long participants look at each face, where on those faces they're looking. The idea here is that the independent variable, right, the thing that we're varying, is the gender of the face, right, male versus female. And every participant experiences both male and female faces, right? They get multiple levels of the independent variable, and they're looking at them simultaneously, concurrently, and we're measuring something about their response to those faces. Now, notice that this differs from an independent or a between subjects design, where if this was a between subjects design, an individual participant would not get male and female faces. They would get just male or just female faces, right? They would not get both levels of the independent variable. They would only get one. So when the participant gets one level, it's an independent design. When the participant gets multiple levels of the independent variable, it is a within subjects design. Now there's another category of within subjects designs called repeated measures. In a repeated measures design, we basically measure people over time. So someone is going to engage in the experiment multiple times over some time span. Now, that time span can be as little as, a few minutes. That time span can be as long as years or decades. But the idea is that we're going to come back over time and assess the same group of people as we vary the independent variable. So in this example that you see here in the slide, participants are tasting a piece of chocolate while a Confederate is in the room. Confederate not being a Civil War soldier, but being someone involved in the experiment, sort of on the side of the researcher. Right? What they're testing here is basically, do you enjoy your piece of chocolate more or less when you're with someone else versus being alone? The hypothesis here is a social psychology hypothesis about does interacting with other people increase enjoyment of activities, or does being alone increase enjoyment of activities? So the first thing that happens is that participants eat a piece of chocolate with someone else in the room. Right? That's the first level of the independent variable. Then they rate that chocolate. Then, presumably, some time passes, maybe a few minutes, maybe an hour, and then they're given another piece of chocolate, but now they're alone. So this is our second level of the independent variable. So the first level was eating the chocolate with someone else in the room. The second level is eating the chocolate alone. And then we have them rate their enjoyment of the chocolate. The idea being this allows us to compare shared experiences, eating the chocolate with someone else in the room. You presumably will comment, "Oh, wow, I love this chocolate. It's so rich, or it's so, bitter, and that's what I like, or it's super sweet," right? Doesn't matter. You're sharing the experience with someone else versus how much do you enjoy the chocolate when you're having an unshared or an alone experience. Now, notice that we have a single group of participants, one group of people who experience the entire experiment. It's the same people. They eat the chocolate with another person in the room, and then they also eat the chocolate alone. So we have a single group of people who are basically doing the experiment multiple times, but we're tweaking things each time they do the experiment. We're changing the independent variable within the group, right? Within the experiment itself. And so we have a different type of design, a within groups design. Now, you'll often see these sort of in two types. The one we have here, which is sort of a rapid fire change, meaning the participant comes into the lab and they might experience multiple levels of the independent variable relatively quickly, as the example is here. Or you see these experiments happening over time. So maybe we're measuring change with age, or we're measuring, maybe medical outcomes over time. And so we're repeatedly measuring people every year, every 2 years, every 5 years. You'll also see repeated measures designs that really extend that time frame for the repeated testing. But the takeaway is that it is a within subjects design because the subject experiences multiple levels of the independent variable. So now let's talk about some potential issues with this type of design, particularly repeated measures designs. So a really interesting area of study is the impact that children or babies have on adults or parents. In particular, the impact they have on like neurotransmitters or hormonal release in parents, perhaps as an evolutionary adaptation to influence parental behavior or caretaking behavior. So we know that the substance oxytocin, right, is produced by your brain and your body, and it's a feel-good substance, right? When you get oxytocin, it does things like reduce pain, and causes sort of positive feelings. And so it's thought that maybe interacting with a child causes the release of oxytocin so that the adult feels good, feels positive, and will thus interact with the child again, right? And continue to caretake for the child. So you can imagine an experiment where we have a single group of people interact with like maybe their child, right, with their own toddler, and then we measure their oxytocin, and then we have them interact with someone else's child, so a new toddler, and then we also measure their oxytocin. The research question here might be, what's the difference between the impact of oxytocin on your biological child versus a non-biological child, right? This is a problematic research design because the order of the independent variable is likely to impact the other level of the variable. So imagine that you interact with your own child and that causes a spike in oxytocin, right? Great, beautiful. That's exactly what maybe we thought would happen. Interacting with your own toddler spikes oxytocin levels. But then 20 minutes later, we give you someone else's toddler to interact with, and then we measure your oxytocin again. But what if this first manipulation, this first bump in oxytocin carries over, right? It's a biological mechanism. Oxytocin isn't just going to go away magically when a new toddler is introduced, right? Maybe that oxytocin level stays elevated. And so the effect of one's own toddler almost, sullies the effect of this next manipulation. The oxytocin is still hanging around from the first manipulation. And so what we've done is confounded our independent variable because of an order effect, meaning that this bump in oxytocin persists for long enough that now we can't tell the difference between the oxytocin impact of your own toddler and the oxytocin impact of a new toddler. So what we can do to mitigate that confound is do what's called counterbalancing. Now, counterbalancing involves flipping the order of our independent variable exposures. So we have one group of participants that gets level A and then level B. We have another group of participants who gets level B first and then level A. And so this allows us to compare these two groups to see if the order of the exposure of the independent variable matters. So maybe the first group gets their own toddler and then someone else's toddler. And then the second group gets someone else's toddler first, and then they get their own toddler second. So we sort of balance out the effect of order by having multiple groups engage in different orders of the independent variable. So this helps us control for those order effects and will help us ultimately statistically parse them out and be confident in our internal validity of our manipulation of the experiment. So I'll give you another example really quickly. Imagine that you are let's say you work for Hilton, and you want to study people's enjoyment of different resorts, different Hilton resorts. So you take a group of people and you send them to the Bahamas. They spend a week in the Bahamas. They give you all this data and this feedback about their stay. Great. Then you take those same people and you send them to, Winnipeg, right? Or Ontario, Canada. And they stay at a Hilton hotel or resort somewhere in Canada. And then they give you feedback and ratings about their stay at the Hilton Winnipeg. So the question is, might there be an effect of order such that if you go to the Bahamas first, Winnipeg sucks after that, right? Like, I was just in the Bahamas, laying on the beach in a bathing suit, drinking Mai Tais and, listening to music. Winnipeg sucks compared to that. If you're from Winnipeg, sorry, I have nothing against Winnipeg. That was just a random city that popped into my mind. I'm sure it's a lovely place. But compared to the Bahamas, perhaps it sucks, right? So if I went to the Bahamas first, then afterwards, Winnipeg sucks. But if I went to Winnipeg first, there's nothing wrong with Winnipeg. I'm sure maybe they have a really cool art scene or a nice indie music, whatever, I don't know. And so if you went to Winnipeg first, you would have a really good time and you would give it high ratings. But if you went to the Bahamas first, then you would give Winnipeg low ratings because the order effect of going to the Bahamas first makes Winnipeg look bad. So what we need to do is control for that effect of order, that effect of the order of manipulation of the independent variable. And what you should do is maybe have a group that goes to Winnipeg first and then the Bahamas, and then a group that goes to the Bahamas first and then to Winnipeg. Or maybe this is a research design where you shouldn't do a within subjects experiment. You should do a between subjects experiment. You should send half the people to Winnipeg and half the people to the Bahamas. But the idea is that repeated measures designs are potentially problematic because if you're doing multiple things to people, the order in which you do those multiple things might impact them, might change the results of the experiment. So we can counterbalance in order to try and mitigate these effects. These are called more generally carryover effects. You might also see these called practice effects when in cases where experiencing the experiment multiple times makes you like better at the experiment. So imagine something simple like I'm a video game developer and I'm trying to study, something about how people behave in my video game. And if I have people play the video game over and over and over and over and over again, then presumably people are going to get better at the video game. They're maybe going to get more familiar with the video game. And so their behavior will change, right? They will have practiced more. And so over time, I'll get a practice effect for people's behavior in the video game. Or maybe I'll get a fatigue effect where, they get worse at the game because they're getting tired of the game. So the idea is that we can have enhanced performance across an experiment with multiple iterations of the experiment. We can have fatigue effects like decreased performance with multiple iterations, or we can have carryover effects. That's more the Bahamas Winnipeg example. It's not that going on 2 vacations makes you better at vacationing. It's just that there's a carryover from Bahamas to Winnipeg. So practice effects, which involve increases in performance with multiple iterations of the experiment, or fatigue effects with decreases in performance. We don't want either of those, right? Those are bad. So we can counterbalance to take those away. And then carryover effects, the same thing, we can counterbalance to mitigate those. Now, this is all good and easy if you only have 2 levels of the independent variable, treatment A and treatment B. That means you just need 2 groups of people. Right? Group 1 that gets A then B, group 2 that gets B then A. But as you add levels, so let's say we have Bahamas, Winnipeg, San Francisco, right? Let's add a 3rd city. Counterbalancing becomes extremely difficult because now we have so many different order combinations that this is going to be really difficult to do. Right now we need 6 groups of people instead of 2 groups. And God forbid you add a 4th condition. So now we have the Bahamas, Winnipeg, San Francisco, and then Chicago. Right? We had a 4th city. Now all of a sudden we need 24 groups of people to adequately counterbalance. So this can get out of hand really quickly. And it's one of the downfalls of repeated measures designs is that if you have too many levels of the independent variable, counterbalancing becomes problematic for time, for money, for resources, because you need just so many groups of people. It becomes a burden to the study. One point I want to make that's really important is that just because I have group 1 and group 2 doesn't mean that this is an independent study. Remember, we said that an independent groups or between group study is one where we have 2 groups that do different things. So even though it's a little tricky, even though we have group 1 and group 2, this is still a within subjects design because everyone experiences multiple levels of the independent variable. Half my people get treatment A and then they get treatment B. The other half of people get treatment B, then they get treatment A. They get 2 levels of the independent variable. So they're not really what we call independent groups because everyone is getting either A then B or B then A. Right? They're getting multiple levels of the independent variable versus a true between subjects design. What makes something a between subjects design is that when we split people into groups, they only experience a single level of the independent variable, meaning they would get this group of people would get treatment B, and this group of people would get treatment A, and that's it, right? There's no repetition. So using our Bahamas Winnipeg experiment, if I have 100 people and I split them 50-50, and half go to the Bahamas and half go to Winnipeg, I have a between subjects design because they experience one level of the independent variable each. Bahamas, Winnipeg. Versus I have 100 people and I take those 100 people and I send them to the Bahamas, and then I take the same 100 people and I send them to Winnipeg as well. That's a within subjects design. That's repeated measures because they're experiencing both levels of the independent variable, Bahamas and Winnipeg. Okay. So that's the issue of counterbalancing is one of the drawbacks of a within groups design. The advantage is that because we're using the same people multiple times, it allows us to control for person level variables, right? People essentially serve as their own control because we're basically comparing them in this situation to them in another situation, right? So if I go to the Bahamas, I am still how old am I? I am still a 33-year-old, white male from Atlanta, regardless of whether I'm in the Bahamas or Winnipeg, right? I can essentially control for like my age, my race, my education, those sorts of things, because I am me in the Bahamas and I am me in Winnipeg. So it allows us to control for person level variables. And so because of that, we need fewer people. So within groups designs can be more efficient, more effective. We can get similar outcomes with fewer individuals, fewer participants. So these designs can be more efficient. A disadvantage is that if you have really more than 2, or especially more than 3 levels of the independent variable, it just gets really complicated because of counterbalancing. So again, we have to. The disadvantages are that we have to do something for order and practice effects. This might not be practical or possible in certain situations. And this sort of idea that more generally, right, it's kind of the same thing as order effects, but that experiencing the independent variable multiple times might change the way that I act. It might change the way I behave. Okay. So which design is better? Is it better to have a between subjects or is it better to have a within subjects? There is no answer to that question. I can't tell you that one is always better than the other. They simply have different pros and cons. So independent subjects designs don't have to worry about order effects. Especially if we do a pre-test, post-test design, we have a lot of really good data and we can compare people pre to post. But we tend to need more participants for those designs because we need independent groups versus a within subjects design, which can be more efficient, especially if we need a lot of people, we can have all those people do the experiment multiple times. That's great. That's really helpful for us, right? It cuts down on time and money, but it can be problematic because of confounds with order effects. So it's kind of tit for tat, right? Neither one is perfect. They both have advantages and they both have shortcomings. So it's all about the experimenter making the decision about the design that makes the most sense for their research question and any practical limitations they might be experiencing for completing the experiment. Okay, and really quickly, how do we interrogate causal claims for these simple experiments? We want to apply the same criteria for validity that we have all semester: construct, external, statistical, and internal. Remember, construct validity is simply how well did we measure our variables. But then now that we're also manipulating variables, how well did we manipulate them? So if I'm, what would be a good example? Let's say I'm studying, the effect of the Bahamas versus Winnipeg, right? Just keep with that, I guess. But I don't allow people to leave the hotel. Let's say that, right? So I take some people and I put them in the Bahamas, and I take some people and I put them in Winnipeg, but they're literally not allowed to leave the building. That's a pretty shitty manipulation because the thing that makes those places different is the stuff outside the hotel, right? The Bahamas or Winnipeg. If I just stay in the building itself, I'm not really manipulating what I think I'm manipulating. So when I decide on how to manipulate my independent variable, I have to make sure that it's manipulated in a good way, right? If I want people to give ratings on their experiences of the Bahamas, I need to let them experience the Bahamas. Let's go deep sea fishing. Let's go ride jet skis. Let's go, play beach volleyball, right? The things that you can do in the Bahamas that you can't do in other places. Versus if I have people in Winnipeg, my manipulation needs to make sure they experience Winnipeg. I don't know. What do people in Winnipeg do? Go play hockey, right? Ice skate. Check out the cool indie rock scene that may or may not exist in Winnipeg. That you have to let them experience the independent variable, right? The place, Winnipeg. And so if my manipulation doesn't allow for that, if I force them, okay, you can only stay in the hotel, you're only here for 2 days, you have to eat all your meals at the hotel restaurant, well then, who gives a shit where I am? It doesn't matter. I'm just at a building in the Bahamas. I'm not really in the Bahamas, right? So we have to make sure your manipulation matters. And so that's part of construct validity for causal claims. External validity doesn't really change here. It's the idea, how broadly do my findings generalize? This is based often on who is in the study. Is my study representative of people in such a way that I can generalize to them, or is it not representative of people? Statistical validity, do I have a statistical difference? And how large is the effect size? At this point in the semester, we've discussed that in terms of multiple types of statistics. So you should have sort of a good handle on, are we achieving statistical significance? Yes or no? And then do we have a robust effect or not? And lastly, internal validity. Did I have any confounds? Did I have any selection effects or order effects? Did I counterbalance my within groups design? Did I have enough control variables or control group that helped me do that? So basically, am I sure that my independent variable is the only thing causing a change in the dependent variable? Right? Do I have internal validity to claim that A causes B? So that is it for chapter 10. Thanks for listening, and I will see you next time.